Hello, hello.
Hello, hello.
Oh my God, we're actually doing this. Hello and welcome everyone. Our first Amsterdam Ruby meetup of 2022. Yeah, I regret it's not live, but at least it's something. It's virtual. Hopefully the next time will be live. So hi, I hope you have your snacks and your drinks here. You had your dinner. Hopefully it was pizza. My name is Rayta, and together with Tom, I'll be your host for today.
Yes, thank you, Rayta. We're not the only hosts today, but we're also your Amsterdam community organizers, of course, together with the colorful Floor Drees, aka Chief Chat and Noise, and the fabulous Arno Fleming, aka Chief Techno, the one doing all the techie stuff in StreamYard today. So they won't be as visible all the time, but they're there, trust us.
Nice. Where do you have a slide with the team?
Yes. Sorry, I'm
Yeah, there they
multitasking.
are. Fabulous Arno and colorful Floor Drace. Hello. So you can join us today. Usually you can join the chatter via through Slack, but Slack has been having a bit of issues. So if you have any questions for the speakers later on, we encourage you to write it down in our YouTube Slack. YouTube Slack, sorry, YouTube chat. So, and hopefully, as from now on, we'll continue organizing these monthly Ruby meetups more consistently. And hopefully, our next meetup can be a real life event.
Yes, just to get some announcement out of the way as well. We have a new website uh, that's been in the works for quite a while, and we haven't had as much time as we wanted to work on it all the time. But yeah, we are very happy with this new design, and we can add some more content that we wanted to add for a while now. I really want to thank Svetlana, who designed this very nice looking website, and yeah, sorry in that regard that it took so long, but yeah, please check it out and let us know if you have any feedback or any typos that we left in, and we will improve upon it. Um, Moving on to the code of conduct, we have a code of conduct. We've already had it, and yeah, you can find it at this particular link. Sorry, I see my mouse is still on screen. But yeah, you can please read the code of conduct if you haven't already. It hasn't changed since last time, but read it as a refresher if you can. Then, Rita.
Yes, cool. Alrighty. So let's get to it. Tonight's meetup is packed with knowledge. You'll learn about the technical depth and the nitty gritty of RSpec. After each session, there's a 10-minute-ish Q&A where you'll get the opportunity to ask questions to our speakers in the chat, in this chat. And our moderators will be sure to to give us the questions, and then we can ask them to the speakers live. So let's start with our first speaker. Our first speaker is Benoit Tigiot, and he is actually not a stranger to the community. Actually, did you know that way back, like years ago, it feels like ages ago, he used to be a Ruby teacher, and I was one of his first students. Now Ben works as a CTO for Regulatory Lab, and today he will talk about technical debt. Hello, Ben. Welcome. If
Hey,
you're
hello.
ready, if you're ready and good to go, the floor is all yours.
All right. Well, hello. My name is Benjamin Udink ten Cate, and I'm here to talk today about technical debt, or more precisely, on how to have a conversation on technical debt, uh, both with your peers, but also with people who are, let's say, less technical. Uh, Disclaimer: this is not a Ruby talk. Um, it's about what I think are two of the core challenges you face as a software developer, which is dealing with technical debt and talking to other people. About me, I've been a Ruby developer since 2010. Currently, I'm working at Regulatory Lab, where we create tools for lawyers and notaries to be compliant to AML and ATF laws. Basically, we help to make the world a better place by preventing criminals and terrorists to launder their money. We're currently not actively hiring, but if you're interested and have a knack for front-end development, feel free to send me a direct message on Slack or find me on LinkedIn. So about this talk, what is technical debt and what does it mean? The term was introduced by Ward Cunningham, an American software developer and one of the co-authors of the Agile Manifesto. The term is a metaphor, which means it helps explain an idea, so you can have a conversation about it. Mr. Cunningham meant with technical debt to make a conscious choice to deliver software faster, to get it in the hands of the customer earlier, so you can learn things that you don't know. So agile software delivery sort of assumes that you don't know everything. You can either spec it out until you have a really big pile of documents, or you can build the first thing that you think you should build and then start learning about it. Well, by giving it to the end user, you can start learning, and you should use those learnings to pay back the debt. So the idea is that you pay off your debt by refactoring your code and matching the business better given what you learned. And by not paying your debt or paying parts of it or paying interest, you eventually end up with impayable amounts, and this will grind your software development process to a halt. This is sort of an old metaphor, so it's about 30 years old, which I think in internet years makes it like 210 years old. That, of course, isn't a problem in itself, but because it's been around so long, it's been reblogged a lot and hijacked and misused and redefined so often that it seems to sort of have lost its meaning, or it becomes like an umbrella term. So I'll give some examples from my work experience and conversations I had on the topic of technical debt to reach a broader understanding of this subject. So, example number one. As a business, I'm trying to keep company names out of this. Example number one. As a business expert, you hire an outside company to build this great app idea you have, and they build it, and it's awesome, and it's a prototype, and you can go out in the world and test it with real customers. And then, of course, because it's a prototype, a lot of stuff about maintenance was sacrificed to get it out and into the world. And you start onboarding customers on your on your prototype, and it actually works really well, and you onboard a lot more without really revisiting the old code. So you end up with an unmaintainable product because any change introduces like 5 new bugs. Another example from my experience, you have a great Scrum team, and Scrum sort of means that you have a lot of non-technical people in the product team. So, for example, you have a product owner, and you work directly with the client. Either it's the internal client or an external client. You have planning sessions every week, where you hash out new features and ask the clients and product owner to give input for priorities. And given that your app has some technical debt, and you want to make the work visible, you start adding it to your backlog, but it never gets prioritized. And instead of fixing some test that runs for 20 minutes that everyone hates, you end up adding a bunch of new features for happy customers. Example number 3. Let's say you have this PHP app, which is not really performant, and it lacks matching your business rules, and it's full of bugs. And you hire an external party to rebuild your product, and they use like a dozen innovation tokens. So they bring out all the guns, and they sort of build a rocket ship when you need something to get groceries. And when they're done, they hand it over to your team, which was building and maintaining the PHP app. Example number 4. So you have this app that's been in development for the past, let's say, 15 years. So there's a lot of business logic in there. And you want everything to become really performant because you built so much on top of it that it really doesn't perform anymore. So you rewrite everything in Go. And instead of slicing things vertically, so picking some data and some business and some view logic, you start slicing it off horizontally and building it on top of the old application, inheriting its initial slowness. I have one last example. Keeping up too many spinning plates. So you have this awesome app that's been in production for, let's say, 8 years, and you started out when React was like, it just was released by Insta, and it was all the rage. And back then, React was nothing more than, let's say, HTML manipulation library. So you wanted to do data management, and you had to write your own version of Flux. And then suddenly Redux came around, and you said, okay, everything we do from now on, we will use Redux. And then Redux version 2 came around. I think it was something. Then Immer came around, and you do the same thing. You say, okay, everything we do from now on, we'll use Immer.js. And then nowadays you have to go back to vanilla React using hooks or something. So you basically have like 6 configurations running for sort of the same thing. And yeah, you end up having to support it, all of it at the same time. So what happens here? I think in all these examples, there's a few red, a few themes. It's mostly about shipping. The company wants to upgrade, ship a new version, get it out as soon as possible. It's about learning from the customer instead of defining all your specs up front. It's about gradually adding changes instead of saying, okay, we'll rewrite the whole thing just now, instead of just introducing it and then gradually adding it. And it's about visualizing your efforts, which I think is really good. It makes you visible, and it makes the work that you do visible. But there are also some things that are not so good. So if you create some technical debt, for example, if you don't refactor existing code at all, and eventually you make it harder to work on the code, especially if you have multiple layers of this. So with the React example, you sort of pay back on the debt, but then knowingly stop halfway. And yeah, then you start accumulating interest, and that will, in the end, become a problem. Something else that's often a problem in these examples is creating a skill gap. So if you grab an outside team or freelancer to build something awesome and then put the existing team on it, then there's a huge skill gap, and you sort of set them up for failure because they don't have the knowledge to maintain the app, and they don't understand most of the concepts probably behind it. Another thing that goes wrong if you don't maintain your tests and if you don't add to your tests, you sort of, in the end, set yourself up for a big rewrite, because as soon as your code becomes unmaintainable, if you don't have tests, you can't really refactor it, because you'll break everything and you won't be aware. And in the end, you'll be like, okay, whatever, we'll just write everything again. And the last thing I think is not so smart is to leave the choice of working on these things in the hands of people that are that don't have the technical knowledge to understand what it means for the quality of the product if you don't write a test, or if you don't refactor your code once it doesn't match your business rules anymore, and instead start piling quick fixes. So I guess the question you might have by now is all of this technical debt? And the thing is, like, when the term was introduced all this time ago, after that, the concept was picked up by a wide community of people, and Ward Cunningham was sort of, how do you say, unhappy with their appliance of it, because many people mistook releasing the code quickly and said, okay, we'll just hack something together, we'll Stack Overflow all the answers, and then just put something that works. And what he actually meant was you should ship high quality code with a lot of tests, and you should do that quickly. And then once you acquire new knowledge, then you can easily refactor it, because the code already really reflects your original idea, and you know how to amend it to fit your new ideas. And besides people misusing it, I think it seems that technical debt is just used for a really broad how do you say, range of topics. So basically almost anything that isn't directly related to functional code comes on the pile of technical debt. So how do you have a conversation about technical debt? If whatever you mean by technical debt requires a lot of investment of time and money, I think it's always good to start a conversation about it, because you will need to get some support. Either get support from your peers, or from some manager or product owner. So how do you do that? I think getting support is about finding common grounds. So I think what really works is to have a conversation with people in your team and people outside your team and asking them what really matters to them, because stakeholders are part of your software development process, all with their own agenda. And if you can sort of align agendas, then you can get support like that, and then which is what you need. So how can you do this? Well, most business people, their minds work a bit different than an engineering mind. So as an engineer, you're really happy if you can solve problems, and if you can learn new things. And business people mostly care about business, which basically means time and money and staying ahead of the competition. So if you want to have a conversation with them, it might be good to learn a bit more about these topics. And I won't go too much into them because I don't think, I think it's too complex for a talk like this. But I think it really pays off if you do. So, for example, you could mention to a business stakeholder that you spend a lot of time reworking issues, right? So you build it, you release it, and then it comes back to your backlog, and you have to do it again, and then you have to do it again, and it sort of creates a false sense of progress, because you're like, oh, I released this within a day, but actually it took you 2 weeks. The same is like if a lot of the work that you do on a daily basis is ad hoc. So let's say, let's call it firefighting. So you come in the morning, and the whole day is like a surprise. If too much of your time is spent on that, that means that you can't really work on other things that are important, like new features for the product. So if you can argue that refactoring some part of the product will improve this, I think you can make a good case. What you could do also is, for example, talk about being able to ship faster. So shipping is super important in our competitive market, and to keep up with the competition and to stay ahead on some fronts, you need to remain this ability to ship your features quickly. And to do so, you need a very maintainable code base, and your build and release process should be top shape. And I think you can imagine there's also other cases to make, like if the stakeholders work with HR, for example, they might have might think that it might be that the thing that matters to them is a high turnover, for example. And you could make your case that working on a code base that's falling apart and being in crisis like most of the time isn't really good for team culture, and improving that will probably also change the turnover. So, conclusions. The idea of this talk came from experience at a workplace where technical debt was used as some sort of impending doom to scare decision makers outside of the technical stakeholders into giving them all the room they thought they needed to work on problems and to solve everything, to basically to leave them alone with their debt. And I want to strongly advise against this because I think it creates a culture of fear and misunderstanding, and in the end, it will really bite you in the butt. I think also by defining the technical debt metaphor as anything that costs money that is not a feature doesn't really work well with business people. And they soon start to get a very negative emotion about about the term and when it's mentioned. So instead, I think it's good to find a common language and maybe educate non-technical people a bit and one step at a time. And I have an afterthought, which is, do you even need to talk about technical debt? Because in the end, you're the engineer and you have the opportunity to just work on it. And as long as it doesn't really interfere with your work and it improves the quality, or at least it keeps it at an acceptable level, then yeah, maybe you shouldn't ask permission and leave be the decision maker. And yeah, that's it. So yeah, thank you. And I think we can do questions.
Yeah. Yes. Hello. Hi, Ben. Thank you. Thank you so much for your technical debt talk. Yeah, we do have a couple of questions from the community. So we have the first question from David Kelly. Some companies have a 80-20 rule where 80% of time is spent on new features and 20% is spent on fixing technical debt. So what's your thoughts on this particular strategy?
Yeah, I think it depends. And I think that's always the answer in cases like this. If it works for your company, then you should definitely have a rule like this. Maybe even add a bit more effort to it, like maybe 30-70. But at the same time, yeah, if the whole product is falling apart, then maybe 80-20 is not a good rule to follow. So yeah, like I said, it sort of depends. But I must say, I do like having some sort of rule like this if the company is strict and there's a lot of non-technical stakeholders involved, because it sort of it sort of gives you room where you can say, okay, I can just do it as long as I keep within the boundaries.
All right, clear enough. I hope the next question also doesn't also apply the "it depends" answer. But do you think there's like a different amount of appropriate technical debt for like a team of, say, 3 engineers compared to 30 or even 300? Like, is there differences that you're like, oh, that's maybe fine? Or
if you're like 30 engineers working on the same product, then I think probably you want to keep it down to a minimum, because there's a book on project estimation that is quite old already. It's the Mythical Man Month, and it talks about the fact that larger teams add a lot of complexity to the software engineering process, because if you're only one person, you have like one connection to yourself, and then if you're 3 people, you already have, I think, 9 connections, and then if you're 30, there's a lot of communication going around, and there's a lot of chance of things going wrong that way. And it also takes up a lot of time. So if then you also need to spend a lot of time on paying interest and on paying down on your debt, then I think you're probably doing it, well, I wouldn't say doing it wrong, but that's probably a better use of your time.
Yeah.
All right.
So we have another question from the community from Jan van der Pas. Do you have a definition or guide that you apply to classify technical debt versus, hey, I don't like how this looks or works? How do you get consensus about that?
Yeah, I think the whole I don't like how this works is more of something that comes with experience in engineering. And once you're like a meteor engineer, so you have a good bit of experience, you think that everything you didn't make is probably something that's not right. And I think that's something that you as a team you should take care of. So if people say, okay, this is not good because I don't like it, then that's a bit flimsy.
It's a bit subjective, like different to everyone.
Yeah, and also, if there's what can happen is that you start rewriting parts of the code that aren't really affecting your maintenance at all. Because if there's some part that you just wrote and you never have to rework it, and someone looks at it and says, okay, this is crappy, this is the worst way to build this feature. But if it works, right? I mean, you don't want to throw everything out and then rebuild it for no reason other than just rebuilding it.
Well, this time you'll get it right? It's no tech debt. All right. Moving on to the next question from Dirk Jan from also YouTube. Do you feel differently about technical debt introduced by engineers versus introduced by the business side? Do you have strategies about post-mortems communicating what business decision caused what debt?
No, I don't have any strategies for that, but that's a really smart way of looking at it, I think, to say, let's when things go wrong or when we evaluate where we are, see how certain parts of the code were introduced that you're not happy with, or that give a big burden on maintenance. And I think in the end you build software for the business. So to make a really hard distinction between that maybe doesn't add too much to a postmortem, but
well, maybe the management side of things, perhaps, if you look at it from that, like constraints and time pressure, I can imagine could be a large factor.
Yeah.
Who knows?
Yeah, but I think as an engineer, you also apply these constraints, not maybe as often as a product owner might, or a Scrum person. But you still try to say, okay, these are my specs, and this is how I'll build it, and then
I think from an architectural perspective, you take both the technical and the business constraints into account, right? Gosh, I really miss the real life events. We could have had such a nice discussion with all the people there. I mean, these questions are amazing. I'm like, yes, we could have so nice conversations about because technical debt, it's a thing. So how much time do you have? Because we still have a couple of nice questions. I think that all right, we have two questions for you, and then we have to hit the break. And I hope the next time when we have a real live session, we can maybe have like some sort of discussion, because I also have so many questions now. So the next one is from Johnny for you, Benjamin. How do you keep the engineering team itself motivated to work on technical debt?
I think that's a really hard one, because if you've ever been an engineer working on on a product that has a lot of technical debt, you know it can be sort of disheartening. And yeah, if you live in a house and everything is broken, then maybe you feel like you don't want to live there. So I think the way to do it is the way to keep them motivated is to give them some ownership on changing things, and to help them to help the team basically to change the things that they think are important as well, next to what the business thinks about it. And I think it's also important to keep communicating clearly. Like if you, for example, set a rule like you can spend 20% of your time on refactoring or improving the quality of the code base, then communicate that clearly to the business and make sure that everyone knows it, and then that there's no shortcuts where people say, okay, yeah, we usually do this, but this month we want to release a feature, so now we're just gonna throw all the rules out of the window. Yeah, so I think that's how I would motivate a team, to just being honest and keeping promises.
All right. Sorry, I'm hearing in my ear that I need to ask a question, that I've lost a question. Floor, can you just post it, the question you meant? Oh, here, I think I found it. Have you heard of the technical debt game? Rayta and Floor played it at DevOps Days Amsterdam, and at a DevOps Amsterdam meetup, and it was a fun game, lightweight to talk about technical debt and velocity. Do you know that game? The technical debt game?
I've seen pictures of Rayta and Floor playing it. I think on LinkedIn.
Yeah,
But,
LinkedIn, Twitter, we shared it on everything because it is a pretty cool game. Yeah, we could also play it on a like a Ruby meetup. I mean, like, yeah, well, technical debt. Oh, it doesn't matter what language you write, right? In order to have technical debt. So, Floor, I know you're not here on visible, but I know you're here, like in the back. We're gonna organize a technical debt game with the Ruby community. So now you know. Sorry. Okay, so we're gonna do this. It's super, super nice. Oh, Floor says like, yay, of course. So we're gonna play this game, the technical debt game. And hopefully we'll have more conversations there, because I think the technical debt is, it opens like this Pandora box, like all this whatever can go wrong, but also like how we can sort of make sure that it doesn't go wrong. So I'm looking forward to our playing this game with the community. I think for now we're out of time, but I'd like to take this opportunity to thank you very much for your time, Benjamin, and your presentation about technical debt. We will have a short break now for 15 minutes. So it's 1940 almost. I think we'll be back at 1955. Looking at you, Tom. 1955 for our next speaker, Benoit, who will talk a bit about RSpec. So go get your refreshments or your toilet break if you need to. We'll be back in 15 minutes at 1955. See you then. Hey,
Hello, welcome back, everyone. I hope
hello.
everyone, I hope everyone got a refill on their snacks and is all ready to go for the second talk. Before we do that, I heard that someone had some show and tell today. So, Rayta, what did you want to show us?
Well, on special request, people are wondering what I'm wearing on my sweater. Well, it's a YAML sweater. It's basically what it stands for. Yelling at my laptop. Well, thank you for noticing.
Sure, no, I was very. I noticed that immediately. But yeah, all that YAML config must drive you crazy.
Yes, so
Um,
happy that we can do Ruby stuff now and RSpec.
just for tonight. All right, but yeah, we have our second speaker, a very special guest today. Benoit is part of the RSpec core team, and I read that he's also a Vim fan, so he's immediately best friends. But today he'll he'll talk about fixing a gnarly issue in RSpec. I personally had to look into some RSpec code as well in the past, just to debug some stuff and blog posts, and yeah, I can imagine diving into that code, and very interested to hear what kind of issue it was. So without further ado, Benoit, please take it away.
Okay. Everyone hear me?
Uh,
I hope.
Yes, we can hear you.
So yeah, my name is Benoit. Actually, I'm calling you from Paris at the moment, but I live in the west of France, in a city called Nantes. I'm working for a company called Lifen, with an healthcare company, who is based in France but is operates in Europe. And this company is providing solution for all the healthcare system. And healthcare system, as you know, especially in France, are complicated. So we do a lot of connection between healthcare system. And we use RSpec, but I was using RSpec before, and I am a member of the RSpec core team since few years. Today I'm going to talk about a specific part of RSpec, especially about RSpec core, called bisect. So first, for the people who may not know RSpec, RSpec is one of the most downloaded library on Ruby gems, and it's the Ruby it's a library, a tools even that you use to write some tests, to test your Ruby code and even further. It's used in a lot of projects, and it's based on a very specific DSL to write your specs. In RSpec, there is a command called bisect, and this command, I will explain how it works, but first, I would like to speak about the origin of the bisect command. And the bisect command is from a tool you all know. It's called Git, and the Git bisect command is very interesting when you want to find a bug that has been introduced previously, but you don't know when. So a clear example is you are working on your project and you see, for example, a visual regression, or you see a test that is failing, and you don't know since when it has been introduced. So you're going to do it git bisect start. You say, I'm going to start the bisect workflow. And then you're going to say, for example, today, the commit I am using at the moment is wrong. So you say git bisect bad. Then you go back 2 weeks ago, you try your code, you try your visual page, you see no regression. So you say git bisect good. And then on the git bisect algorithm, it's a binary search. They will split in this interval of 2 weeks, and it will put you in the commit where you will try again if there is the regression or if there is the testing issue, and then you try again, and then you mark your commit as good or bad, and then you go on and go on, and at the end you will each git bisect will show you the commit that introduce the regression. So it's a tool that is very, very useful when you don't know when a regression was introduced. So for RSpec, there is RSpec bisect, and it's pretty similar to git bisect, except instead of commits, we will work on testing expectation, so it block. So it's very interesting when you have like a random failure in RSpec and you don't know if there is link between each test. So the RSpec bisect will split your test suite in different parts and will tell you if I run the test A, B, and D in this order, you have this kind of error. So it's interesting when you have random failure in your test suite. So here is a basic example with a basic class called Eurico. I'm super happy it's happening soon. And there is a class variable with a very basic method. And we have here the RSpec code where we have two tests. The one is doing a very basic EQ true, the second one too, but we have also here a mutation on the class variable soon. So if we run the test with the very basic RSpec command with Ruby code, then we define the order. We see that we expect the first, then the second one, and everything is working well. If we run again the test, but instead of specifying an order, we choose here a random order, and then we see that if we change the order, soon is mutated, so the first test is not good anymore. This is a very basic example, but it, for example, is in this type of test. If you run the aspect with the bisect argument, you will see that's a different output, and RSpec will look at the failing example and check if the failure are order dependent. So sometimes it's only even in random order, it's just a different test, but for example, it will tell you checking that failure are order dependent. Then at the end, you will see the minimal reproduction command. So it's a very basic RSpec syntax with the first describe block and the first it, and the first describe block, second it, with the seed for to run the test. So RSpec bisect will give you the command to run your test again and find which one and which order or which type of test are making the failure. So the command is powerful, but it will help you if you have random failures. It will return, as we saw, a small compilation of tests to run, and it can be replayed. So, for example, if you have lots of test out, a very long test output when you're running bisect, you can run a bisect on the result output. So it will try to reduce the amount of test for the combination of a failure. But there is some cons. It's costly in time because it tries to run your test multiple times. You can try at least for at least 5 times to again until to telling that it's not able to find a failure. And sometimes if the failure it's too random, which happens very often in a code base, Bisect cannot find it. So it will tell you I'm not able to find it. Even if I run multiple times, I'm not able to find a failure. There is a tips for that. You can enable verbose mode in the git bisect, and it will print the command when it's failing and when it's not failing. So you can sometimes start in the middle of the bisect, telling, oh, on the second try it failed, but it never failed after. So I'm going to start from this command and then again run a bisect. And there is last con that we work on it today. Sometimes on big test suites, git bisect can get stuck. So the issue is pretty old, but it took some time to fix it. So this is an issue opened by David on RSpec core repo. In RSpec, you have not one repo. You have very different repo. You have RSpec core, expectation, you have RSpec rails, and stuff like that. So it's a multi-repo, and RSpec bisect is implemented in RSpec core. So the issue was in RSpec core. So in the report, we saw that we see that there is the command bisect is way too long. It's normal that it's too long, but in that case, it's way too long. David is good at providing us a lot of info in the issue. So he used a tool that is very interesting called SSTrace. And what's SSTrace? So it like show what's happening in RSpec bisect. RSpec bisect is doing two things. First, when you run the command RSpec bisect, it will start a process. And then the process starts sub-processes for each part of the test suite we will run. For example, we try to run a failure. First is the main process. Then you have one sub-processes. After the sub-process say, oh, I find one error with this kind of test. Okay, one new sub-processes with just a subset of test. So we create a lot of sub-processes if you have a lot of if it's hard to find the minimal reproduction script for you. And we see in it's very small. I will share the slide after. But here there is something called people, PPPOL, and this is called from the lower side of your OS, who is waiting for a file descriptor. I will explain a little bit later what it is, but is waiting some events on the file descriptor. So the main issue is there is a wrong handling between the parent process, the main process, and the sub process. There is a wrong communication. There is some information that are not working between each processes. So the main RSpec command is not working well with all of the sub processes created by RSpec bisect. And also there is one thing that is more challenging. It's the problem is different on the OS. For example, in our case, we will see on the Mac OS. So first, RSpec Core is and all RSpec projects are pretty complicated code base. So it's always for me, a first challenge is to try to reduce and find the easiest way to reproduce the error. In that case, it's an idea from Balkan, and we are trying to see if there is an issue with the amount of tests we are trying to run under a bisect command. So in that case, you see that we can use an unfetched, so we can easily try to run 2,300, whatever number of tests, and we can see that there is very interesting results. When we run on the Mac, we see that the bisect command gets stopped if you have a 1,504,407 it block. And if we add one more, it gets stuck. So there is really an amount of tests that can be run, and if the RSpec bisect try to run too many tests, it can get stuck. If we try to add some puts message in the code base, we see that in RSpec Core we have this line write.io with the write method. This is where we get stuck. This is where if we put puts before, it's okay, and after it get blocked. This line is important for us because it will send. This code is for the sub processes, so it's the part of the RSpec core that we run very small part of the test suite, and this part when we do this, it sends the information, for example, the command line, the list of tests executed to the parent processes. So in that case, it's not able to do it. It's not able to write it. So again, RSpec Core is complicated. So I try to reproduce this issue completely outside of RSpec and with a very basic code. So as I mentioned here, we are using a file descriptor. File descriptor is something that you all use, but sometimes do not know. It's a sort of a text file on your computer that you fill with some data. And a file descriptor can be a socket, it can be a text file, it can be whatever. But it's only a file when you put some data and you read at the same time, so you can stream data on the file descriptor. So in this piece of code, this is what we are going to do. We just at first look at the process PID, so we just return the integer of a process for the information, and then we just store an IO pipe, so it's a file descriptor, it's the same, and then we're gonna loop we're going to add a lot of data, some data to this IO pipe. So we have a file descriptor, and we just put some data in it until it's over, until we'll see what's happening. So the video is quite small, but I will share you some screenshot after. On this video, I'm going to do two things. I'm going to run the script we just saw before, and I'm using a command that some of you may know. It's LSOF. So LSOF is for list open file. And list open file is often used when you have, for example, you raise application and you want to know if it's still running on which port of your computer. So you can easily check if there is a process connected to which port, and you can easily kill it or know if it's still active. But in that case, we're going to use it because it's LSOF, it's for file also. So we can use it for looking if we have file descriptor open and also the size. So in that case, what I'm going to do, I'm going to run the script. So you see here that I'm using the script. My command is on the top. And what I'm going to do is I'm going to look at what is happening when I'm filling some data on a pipe, on a file descriptor. And you see that at first we have only this amount of the pipe size is only this. And quickly the pipe size increase because we request some size, so the pipe size increase. And we see that it keep increasing on the top, and then it stop. Even if I don't stop the video, it stop here. It is not able to write any more data. And if I keep continue, we see that it's not working anymore. I cannot write any more data. So the code is the Ruby code is stuck, doesn't able to write any more data. So we'll see a better screenshots. So here is my code with writing some data. And here is the second part where you see the name of my process, the ID of my process with the PID, the type of the file descriptor, and also an ID, and here the size. And this size is this is what is interesting here, is a limitation of my OS. So it means that I'm trying to write some data in a file, and my macOS tell me you don't have enough size. You cannot write anymore on this file, so I'm just block the instruction. I'm not giving you an error. I just block the instruction. You have to come to this file descriptor and read some data, remove some data, so you will be able to again write it. But you have hit the limits. It's really similar to hard drive, but on a very, very small small file. So if it's a problem to write data, maybe there is a method in Ruby that can help us to write some data without any limitation. So there is this method called write non-block, but it's worse because when you hit the limits, it will just raise an exception. So this is not what we want. If we use this, for example, you run your test suite, you run bisect command, then you have a very, very long and complex reproduction script, and it will just explode and break the RSpec command, RSpec dissect command. So the problem, if we resume at this point, is the main process, the RSpec process, start multiple bisect subprocesses for each subset of spec to run, and for that using a fork. So it just creates a new subprocesses. But the subprocesses is way too big, and the file descriptor is too big, so it gets stuck when you try to write. And in the code base, to continue the execution, we have a method called waitPid. So this is a part of the code where we wait the subprocesses. We say, did you finish running the subset of the test? But because the command is blocked before, we are not able to continue the restriction. So we are getting stuck. To fix this, we could read the content of the file descriptor, but this is something we do after the waitPid. So there is a problem. So at first, the solution was to remove the processed waitPid. So we see the pull request is quite simple. This is the code before. We create a PID. So here's the command to run a subset of the test suite. And then we wait. Here is the command that say, oh, you didn't finish. You didn't finish. I'm gonna wait. But what I did is I just removed this. I create a test, then a little explanation, and then boom, fix it. But just a few months after, someone wrote this blog post and explained that what I did was wrong. So we released the fix. So the fix I did was in a new release of RSpec core, but this is not the correct solution, and it is well explained in this blog post. So we will see what is the new issue I introduced and how I fix it, and also how I measure it. So by removing the wait PID that we saw in the previous pull request, I created a new issue because what wait PID is doing is waiting for the processes or the sub processes to finish, and it also will do some cleaning parts. So if I'm not taking care of these sub processes, they will remain as zombie processes, and zombie processes is like you have some log of a previous execution, but in the case of processes, this is stored in a table, and the table is also a limitation. So what can happen is for example, you create a lot of command. You do not take care of cleaning of the sub processes of the processes when they are killed or terminated, especially when they are terminated. And what will happen is there is a limitation in your table, and when you hit this limitation, it's globally limitation to your system. So we will see what's happening when I'm not doing the wait PID. Just one things to know: when you kill RSpec, if there is zombie process created by RSpec, they are removed because this is the RSpec, the main process, and it clean everything. So this is not something that will remain dirty after you have closed the RSpec command. And you will see that you fix this so you don't have to care about that. Also, a little command I discovered when I was working on this. This is the number of the processes, the number of processes you can use and create in your computer. This is the number of processes globally. This is not limited to Ruby or to RSpec. So this is not a huge amount of processes. You can easily hit this limit. So again, a very, very basic Ruby code. Here it's very similar to the code from RSpec with the right. Here we create an IO pipe, and here we just create in this IO pipe some data, like very similar to the file descriptor. And here we're gonna hit very close to the limit. We see that there's very close to the OS limit on the pipe size. And here we just create sub processes with the run spec and the fork. And then in this sub process, we just gonna create. We're never gonna wait PID. You see here it's commented. So we're gonna create zombie, and we'll see what is happening. Here just some logs. So this is pretty small, but you will see we're gonna stop and we'll explain. So on the first tab on the top, first window, I'm just running the Ruby script we just saw before. Here on the script, I'm just looking at, with the ps command, I'm looking at the zombie script. And on the third window, I'm doing quite the same, but with a little bit more data. So I'm showing all here's the count, and here's the list of scripts. So here I already have one zombie process, but it's globally. And then if I run the come on, sorry, I start again. And here, if I run the script, you will see the increase of zombie processes that will go very fast. So for example, you see I have one, then I run and see 14, 43, 74, and then we'll see when we hit the limit, what is happening. So I'm trying to do some ls on the window, and then what is happening is at the end, I'm not able to open even a window on iTerm. It completely block the system. So you have to imagine that you are working on a remote system and you try to run the RSpec bisect command. It probably takes at least I don't know, 1 day, 2 days, you have a very big test suite, and then all your system gets blocked, like you have big issue with the system because you fill up the kernel process table with very dirty process, zombie process that should be clean. So there is one solution that is pretty obvious, but you have to know the Ruby API. It's called detach. It's on process. And what detach do is detach does it's exactly what we are doing before with the wait pid. So you want to look at the status of a task of a process, then clean it. But the thing is good is create a thread, so it's async, and it will not be it will not be a blocking solution. So this is very interesting for us because we want to create a fork with sub-processes and all of the subset of tests. This is not blocked because we will look at it after. But just after, in the sub-processes, we're going to look at we're going to read the file descriptor, and the file descriptor will be cleaned, so it will be able to do the wait pid and the clean. So it's exactly what we want, a non-blocking action. And this process detach, it's exactly what we need. And the definition on Ruby API is pretty clear, and this is exactly what we want because it's mentioned zombie processes, so it's exactly what we need. This is the code for the test because I had to write test to see that I'm not creating Ruby zombie processes when running RSpec bisect commands. So this is this is the code for the spec. We run a test with the bisect command, and this is a lot of tests I'm running, but it's very fast because this is a very small test. And then I wrote a very basic class that will just run the PS command that we saw before. So it's really a Unix command, and this command will look at processes and check if there is zombie processes, and then we do the expectation. If we have zombie processes, then the test failed. So this is how we test it, and yeah, the patch is only one line. It's a lot of digging, but it's only one line. So here's the few things I learned. It's learn tools to monitor your system, because maybe if I look at if I knew that I could create zombie processes, I would have run the test suite or run a complete bisect command and find that I was completely increasing the number of zombie processes. Read a lot of Unix and OS X documentation, because it's often very well written and you have a lot of information, and to be honest, it's accessible if you take time. And sometimes the solution is simply on Ruby API, as you saw before. It's even if you look at the Ruby documentation, you look at zombie processes, and you have a method for that. And the RSpec code base is still complicated, as you saw. I have to move outside of RSpec to be sure I was not having some noise from the rest of the code base. And that's it.
Yay! Thank you.
No.
Inception.
Yeah, let's remove that. No, that's not the thing I wanted. There we go. All right. So you dug very deep, and the solution was a one-line.
Yes, but it took some
fix.
time. Yeah, and it's good
Yeah,
to measure and to know you have Unix tools to check that you are properly fixing a bug, and yeah, otherwise it's you cannot fix that without measuring and validate your assumption.
Yeah. I ran into a very similar issue recently about zombie processes, and unfortunately, that's not a process that will eventually end, and it can, like, I need to reap those processes. I don't think process detach is in like other languages than Ruby, thinking like just C,
Yeah.
C itself. So unfortunately, that's not a solution. But as you said, it spawns a separate process that will check if the process has ended, and then just
it's a thread. Yes.
yeah.
So
Sorry.
yeah.
All right. Cool. Maybe that will inspire someone. What other questions did we have, Rayta?
Oh, well, we have a couple. So let's see. Oh, there are quite a. Okay, so well, my question. I had a question for you as well, but it's not particularly related to the bisect topic you were discussing today. But I'm very curious. Do you know regarding regarding RSpec? Are there any other new features on the so-called roadmap? I know open source, but still roadmap. Do you have one?
It's complicated because RSpec is an old project, and we are maintaining a lot of Ruby version. So it's hard to make big change. And for example, maintaining RSpec files take a lot of times because we have a lot of matchers, and we have sometimes very close to the internal code of Rails. So for example, RSpec Rails brings a lot of work for RSpec. But there is at the moment there is no huge features that are coming. It's always very small improvements, but there is no for example, parallel test. This is something that people are wanting a lot. There is few proposals, but there is not. I'm not going to tell you that RSpec parallel is coming next week. Yeah. So yeah, it's more maintain mode, but there is always a feature that are provided by other people outside of RSpec, because it's a complicated project, and bringing new features, like for me, it's very time consuming. So it's hard to contribute with a big feature.
Yeah, I totally understand. Oh, just curious because it seems like a very popular testing tool for Ruby.
Yeah.
I think we have more questions. Tom, you want to take the next one?
Yes. I was checking if we which one. Do you have any specific features in RSpec that you maybe worked on that you're very so attached to or very proud of, that you're like, I want more people to know about that, other than, say, bisect?
I didn't write bisect, but it was my own Matson who wrote it alone. But in feature I enjoy, not sure, because to be honest, a lot of time I spent on RSpec was maintaining the CI. Because for example, on the previous mod for RSpec Rails, it was we were testing a very different Rails app, so we were building app. So I spent a lot of times maintaining the code base, and not that much creating new features. One thing I wanted to know was to have a custom matcher for but very complex matcher for all the RSpec, the JSON stuff. I wanted to have something more easy to plug for complex structure, to have a better output. I know there is a lot of extension, but I wanted to have something that is very easy to plug to RSpec. Like for example, I work on something that that will help you if you have a very long string, to tell you in the difference in a very long string, to something that is a little bit smarter, that there is a difference in this long string. You have to just print some stuff if you want to have a better output. So this is something that is it's interesting to contribute to have better matcher, but it takes some time because you have to be retro compatible with a lot of version, and also you have to be in the mood of the aspect evolution. So you have a lot of people who want to keep the same behavior. So you have to be careful with that, to not break the compatibility and the usage of the people who are using RSpec.
Okay. So sounds also like maybe technical depth in that regard, as you say, like supporting many different Ruby versions.
Yeah.
Would that make your work a lot easier if you like only have to support the last 2 Ruby versions, for example? Is that like something you're considering?
Yeah. But for example, for an example, we have a lot of meta programming in RSpec, and when they introduced the new arguments around Ruby 3, we had some discussion, and I think I tried to open 2 pull requests, and some people tried to open other pull requests to fix the warning we were seeing in Ruby, and we were not able to fix it. So at the end, it was people from the Ruby core team who came and opened a pull request, and it was even used to Bameter who went to the on RSpec repo to publish a pull request to fix the warnings, because we had too many way of handling this subject, and it was very complicated. So this is, for example, sometimes a very small thing with removing warnings, and it's very complicated because RSpec code base is complicated. So, for example, just removing a warning from Ruby can take a lot of time.
All right. Rayta, did you have a question?
No, just you can go ahead with the last question, Tom.
Okay. We've had a question from David, who asked, I think at the beginning when you were talking about LSOF and SSTrace, if it maybe also this would help, or any other tooling would help trying to debug similar issues with corrupt caches, or he had locks on certain sidekick jobs, and he was wondering if there's like testing situations where one process is writing to a cache and another one's trying to read it, if there's like tooling that you can suggest maybe like these two.
I'm not sure
before?
because it depends of the OS also. Because, for example, I was very surprised on macOS to do not have that much of tools, and also there is a lot of documentation for Unix tool and Linux tool, and sometimes you have different arguments when you are using macOS. So it depends of the system really. And I don't know if maybe share. I'm on the Amsterdam Slack, so please share your issue, and I will tell you if there is a tool for that. I'll be happy to help.
All right, so David, if you have you can post your question on Slack,
Yeah,
with all the information you have, and then Benoit can take a look.
2014, right? Just one more final question for you, Benoit. So what's the size of the RSpec maintainer team?
Oh, it's very small at the moment. It's 3-4 people.
Oh,
The team is much larger, but the people who are active, and I'm less active because family and and work. So it's harder
yeah.
to work at the moment. But yeah, it's not that much people. But sometimes you have people, for example, in with the upgrade of RSpec Rails. For example, in RSpec Rails, there is a lot of people who need the update for Rails 7, for example. So you have a lot of contribution when the people need a new feature or want to fix warning or whatever. So there is a lot of contribution from outside, and there is a company that sometimes tell people to take some time and to contribute to the project. So I find it very interesting sometimes to have, for example, people from Evil Martian or from Procore, from company like that, who came and bring a lot of sometimes big functionality. Like there is a new feature in Rails, and they bring all the matcher for active job or for the mailer, for stuff like that. So, so it's more this kind of contribution that bring new features, and the RSpec core team core team is working more on maintaining the stuff and providing a little fix, follow all the new Ruby version, because it takes already a lot of time.
Yeah. So how can new people get involved then? Just send in a pull request, or how can they help you more?
Yes, there is some issue reported, but most of the time there is already open discussion. I'm not telling it's all issues are hard to contribute, but sometimes you have to don't think it's easy, because even starting from the installing the project, installing the RSpec core, it's complicated. It's a multi-repo, so you have to do a bit of setup, but we try to improve that. So we write some documentation. So we try to the CI is more readable. So when you have an error, it's not hard to find. But yeah, you can really scroll the repo. We do not have a we do not tag issue if easy for a first contribution or stuff like that, but you can easily scroll on the issue, and please do not try to fix issue with a lot of discussion or open since a very long times, because you will do not want to contribute to RSpec anymore after that.
Okay. We'll have a look at the repo first then. So thank you so much for your time, Benoit. I'm very happy that we could meet like this virtually, since you're in France and not in Amsterdam. So hopefully next time when you're in Amsterdam, please
Of
hit us
course.
up. We would love to invite you to our meetup as a speaker, maybe also as a like an attendee. We'd love to have you here. So for everyone out there, thank you so much for joining us today. So our next meetup. Yes. So speakers, we hope you enjoyed the talks. And do you think that you also have an inspiring, exciting, or a topic you want to share with us? You can let us know. You can reach us through the Netherlands.rb Slack, or you can DM us on Twitter. We're not that bad. We're a friendly bunch, really, and we welcome everyone who wants to give a talk, even if it's your first time. You want to kind of like try this thing out before this big conference, or maybe it's your very first talk ever. We welcome that. Like, we can even help you with kind of maybe even designing your first technical talk. So if you haven't spoken on one before, or on a meetup before, we're here to help. We would love to hear from you. So our next meetup. Yes. Oh, yes. We
Yes,
hope
before
for
that.
life. Go ahead.
Yes, so we are thinking about doing meetups in person again this year in some future event. We're not quite sure yet, but we're keeping an eye on all the things that are allowed. But yeah, we'll be needing location sponsors again, because can't have everyone come over to people's houses. So we need location sponsors, like companies that want to open up their doors after everyone's gone home for a meetup. So we will sponsors can sponsor drinks, location, food, and then yeah, of course we need pizza, because pizza. So yes, have a look at our sponsorship page to see what you can sponsor or want to sponsor, and contact us if you need more information. We also need to maybe update that page some more, where it's still the website. We still need to do a lot of changes, I think. So yeah, and hopefully we'll meet again in March, either virtually or in person. We'll let you know.
Yeah. So if your company is looking for Rubyists, this might be the perfect opportunity for them. So just feel free to kind of like ask within the company, hey, we have this excellent, amazing group of people, and they want to have this awesome event here. What do you think? Hey, Arno.
Hello. Yes, I thought I'd just join for a small bit. Yeah, I completely agree with what you're saying. So, indeed, I've just heard that it's very hard to find Ruby engineers. I also know that we have a fantastic community. So, let's just meet at your place. And indeed, what Tom said, we do love pizza.
Sorry, what? At your place? No, you cannot meet at my place, Arno. I'm sorry.
No, at
Oh.
the company's place that is actually looking for new colleagues.
Cool. Well, happy to have you here also for a little while to do our awkward wave. Floor, I know you're out there, and I know you cannot be online for reasons. So I'm gonna like do the wave for you, okay? And for everyone
Is this
out there,
awkward enough?
oh, you're always awkward, but in a
Okay,
good way. In a good way. In a good way.
I guess.
Bye.
All right. Bye, everyone.
Okay, doei.
Bye. Yo, bye.
All right.